Hello, everyone, and welcome to the My Healthy Home Summit. Thank you for joining us. I'm your host, Caroline Blazovsky. I'm a national healthy home expert and an environmental residential consultant with over 24 years of experience. This summit is designed to educate you about the process of creating a healthy home, to learn how our homes may affect our health and wellness, and the benefits associated with living and working in healthier spaces. We've compiled the most decorated speakers in this arena to help you on your journey. Today, we are joined by Allison Bailes, who will be discussing Does Our House Have to Breathe to Be a Healthy Home? Welcome, Allison Bailes. Thank you so much for joining us today. We are thrilled to have you.
Oh, well, thank you. I'm happy to be here.
I'm so excited to speak with you because you and I really have never gotten the opportunity to talk one on one. So I'm looking forward to it as well.
As am I.
As a building science expert, can you start by giving us a quick synopsis of your background? How did you get interested in healthy homes? How did this passion for you start? We find that most of our experts have this really interesting story as to how they got into this industry.
Yeah, so my path is buildings. Well, first energy efficiency. I wanted to build a really energy efficient house, a green house, and I did that 20 years ago. And that led me into building science because just energy efficiency is not enough because you can rot your house down if you build an energy efficient house and you don't pay attention to what happens with moisture. And you can cause serious health problems if you build an energy efficient house and don't pay attention to indoor air quality. So that led me to building science, and building science led me to healthy homes and indoor air quality and all the rest. So yeah, it's the whole package. That's-
And what's your background? What's your education
oh,
like, and what did you pursue?
background. Yes, my background is physics. I've got too many degrees in physics, including the PhD, and I my building the house happened when I was teaching physics at a university here in Georgia, and I knew that job was not gonna be a career for me, so I bought some land, built a house, and that launched me into this new career.
Excellent. I love that. So let's just get into it because we're talking about building science today. Um, and I think let's just throw out the elephant in the room, right? We've talked about houses and we've heard a lot in this summit so far about people saying houses need to breathe. Houses have to have airflow. Houses have to ventilate. An old house is a better house because it's got windows that leak. Let's talk about the myths and the truths surrounding that topic. And you're the expert. You've written books just about this topic alone. So let's kind of get into what are some of the myths and the truths about breathability in a home.
Yeah, so you mentioned the book. The title of the book is "A House Needs to Breathe," or does it? And my answer is no. It's on page 23. You don't have to wait long to get that answer in the book, and I'm giving it to you here easily. The problem with the leaky houses, houses that have lots of infiltration, and indoor air quality in healthy homes is that where is that air coming from? If you have an attached garage, you're getting air from the garage, and most garages that I've been in don't smell very good, and that's a good indicator that that's not good air. If it's sitting on top of a vented crawl space or an unfinished, unconditioned basement, that's moldy and wet, that kind of air is coming into the house too if the house is leaky. You don't want that. You've got a house with an attic that's been accumulating rat feces and dead squirrels for decades. That's not the kind of air you want to be bringing into the house either, especially if people have put poison up there and rat traps. And so that the idea that a leaky house is going to lead to good indoor air quality in a healthy home is just absolutely false.
Interesting. And probably a lot of our audience is just mind blown right now. They're going, "What? I thought I lived in a house. That's really good." So, um, this brings me to a question. So, we have a lot of old houses that are not retrofitted, right? We can't do anything with them, or it's very challenging from an economic standpoint. Homeowners don't want to do a retrofit, they don't want to make their home energy efficient. And then we've got a lot of new houses that are built that are energy efficient, but they're not done the right way, right? So, they're super tight with none of this air. So, can you kind of talk a lot about how do we deal with these scenarios? Like, it's confusing to me as an environmental consultant when I get into these spaces because there's all this great theory out there, but how do we implement it in our homes and make it real?
Great question. I live in an old house myself, 1961 ranch house in Atlanta, and it's been I bought it 5 years ago with my wife and have been doing a lot to it. My father-in-law, who owned the house before, had done some stuff on my recommendation, so it was already fairly airtight for a 60-year-old house, and I've made it more airtight, and now I'm renovating the basement, making it more airtight. So the but how do we address all these old houses where it's difficult to know what to do? Number one, airtightness. Make the house as airtight as you can, and with an old house, it's still probably going to be fairly leaky. Like my house is about 8 air changes per hour at 50 pascals blower door number. So but the code in Georgia, if I were building a new house in Georgia right now, it would have to be 5 air changes per hour at 50 pascals, and I'm at 8, so it's still fairly leaky, but before all this work happened to it, it was probably at 15, maybe even higher air changes per hour. So, it's gotten better, which is good because we're getting, less bad air from the attic. The attic is in much better shape now because one of the things we did to make it airtight is encapsulate the attic, and the, um, the air tightness stops, or reduces the amount of bad air coming from those other places, the garage, the attic, the basement, the crawl space, and it, but you can't stop there. Air tightness is really good, but you can't stop there because then you can end up with problems because you generate pollutants inside. Some are still coming inside from some of the leaks that you have. So you have to do the other things. You have to do ventilation. You have to do filtration. You want to do source control, make sure that you don't bring extra bad stuff in the house or do bad things in the house that create lots of pollutants that make you sick. So, and then moisture control, pay attention to what's happening with the water because you got moisture accumulating behind the drywall in a wall cavity and growing mold, and that mold can, the spores can get out of there and into the house. So, there's you need to do a bunch of it, and fortunately, another good thing that's happening these days is that we have an abundance of fairly low cost indoor air quality monitors. So you can put these things in and monitor the particulate matter. You can monitor VOCs. VOCs is a tricky one. We can talk about that a little bit more if you want, but you can monitor radon. I've got a continuous radon monitor in my house. So there's a lot of things you can do, and for older houses, I would say start with air tightness, and then make sure to do these other things. Add more ventilation, filtration, source control, moisture control if you need that.
So let's talk because our audience is so vastly educated on this, right? We have some people that are super educated, some people who don't know a lot. When people say, okay, well, how do I know what my air changes per hour are? How do I even figure this out? Like giving them an example as to where they can go and how they can do this.
So that's an easy one because if you want to know how leaky your house is, how much infiltration there is, the air changes per hour that I mentioned before, all you have to do is search for blower door test in your area and just go online, do blower door test in your area, and there there should be, well, if you live in a big city, there will definitely be people. If you're in a rural area, that you might have to pay them for some travel, but it's a very easy test to do. They can set it up in a doorway, close up the house, make sure no combustion appliances are going to run and things like that. Depressurize the house to a certain pressure difference between inside and outside, and measure the amount of airflow through the fan. That tells you how leaky the house is when it's under that pressure. Under normal conditions, under the natural air pressures that exist, the amount of air leakage you have is a lot lower. That's why we call these numbers air changes per hour at 50 pascals. Normally, you might have only like 2 pascals or 4 pascals or sometimes 0 pascals. Pascals, the unit of pressure.
Mm.
So the um, the blower door test gives you that information, and it's a really really important number to have, and it's not that expensive. I think for maybe $200 if you don't have to pay for travel, you might be able to find out how leaky your house is.
Are there better and worse contractors to do it? Like I know in our industries, right, we talk about is there a better place to find someone who's more accurate, or is it something that people usually do pretty well? You don't have to worry about them not. completing the task well.
Yeah, there are some certifications that people can get. There's, the Building Performance Institute has several certifications that people can get that will certify that they know how to do blower door testing and other analysis methods for testing homes. And there's home certified home energy raters or another source, and sometimes they're the same people. Sometimes people have both certifications. So look for somebody who has some kind of certification. So there are also statewide certifications, like because a lot of state building codes require this blower door testing, and so there are people certified through the state system.
Hmm. So now you know you've got your information, right? You know how much air exchange you're doing. Where's the next step for them? So they've done their blower door test, and now they want to start sealing everything up.
Well, then you hire somebody who can come in and do the work. A contractor. So there's a classification of contractors called home performance contractors who do that work, and they look at the house as a system. The house as a system is really really important way of thinking about things work, how things work, because the hip bone's connected to the thigh bone, and when you make one change in a house, you could be affecting other things. Like you, if all you do is air tightness, if you make the house more airtight, you could be trapping pollutants in the house that we're getting out before.
Sure.
And so the house as a system approach is really important. Find somebody. BPI has also certified contractors in addition to people who do the assessments and testing. So find somebody who has that kind of certification if possible. If not, just look for somebody who's a home performance contractor. See, ask for references, the usual contractor stuff. Vetting a contractor.
Do you think that's the best place to start? So when people are looking to create a healthy home, do you think that's the best to start sealing it up and then start being able to bring in some sort of ventilation? And we need to talk about that. So once it's sealed, you don't want to just leave it sealed like you discussed. What are some of the options for people to start ventilating it and bringing air in? Because you do think it needs air. It just wants to be air that you're dictating or controlling. Is that correct?
Yes. So your first question, my answer to is yes, air tightness is the first place to start. You will get the most bang for your buck with air sealing. And the other reason to do air sealing before other things like insulation, if you're trying to make the house more efficient, is that if you go and put insulation in first, it's covering the places that need to be air sealed. A lot of people will use, they want to reduce their energy bills, for example. They have an insulation contractor come and blow more insulation in the attic.
What a
The
mess.
yes,
That's all I can, then I've got to deal with it.
yeah, and, if they're blowing it on top of the old nasty insulation, I mean, that's a problem in itself, and then if they're blowing it over the air leaks, so you've lost your chance to air seal, seal up those big holes in the attic that exist a lot of times.
And when you're talking about air sealing, I want to explain it to the audience because they probably don't understand what that means. What is involved with air sealing?
Good question. So air sealing means finding the holes that are, um, gonna bring in most of the infiltration that you don't want in the house, and the bad holes are usually low and high. The holes in the middle of the house, not so important for a couple of reasons. Number 1, it's, outdoor air coming directly in through those usually, and number 2, there's not as big a pressure difference across those most of the time, unless it's a really windy day. But the low holes and the high holes, like at the crawl space in the attic or the basement in the attic, are the really important ones because of this thing called the stack effect. Now, the stack effect is warm air rising, and when warm air rises, if it finds a hole at the top of the house, it's going to leak out, and that means outdoor air is going to leak in at the bottom. This is mostly a winter phenomenon, and the colder the climate, the worse it is. The taller the house, the worse it is. So you want to seal the holes at the top and the bottom of the house. They're a lot more important than the holes in the middle of the house because
Hmm.
you get a lot more air leakage in those places.
That's an interesting way of looking at it. And explain to our audience too. Um, Houses are built very differently than a commercial building with the HVACs. Very different. Can you kind of explain what makes houses more prone to problems because of the fact and the way our HVAC, our heating, ventilation, air conditioning operates?
Oh, well, commercial buildings have their problems too.
Yeah, they
But,
do.
um, so in houses, the heating and air conditioning system, it depends on very variable. It depends on what part of the country you live in. If you're in the northeastern United States, your heating and air conditioning system is probably in the basement. And if it's a nice finished basement that's conditioned, that's great. But a lot of those older homes, they're not. They're nasty, wet, dirt floor basements sometimes, and it's, if you have a forced air system going through a space like that, you can be, on if you have leakage on the return side of the ductwork, it can be sucking that bad air in and sending it through the house.
Mhm.
So, that's one of the issues, and, uh, I've got tons of photos of filters in nasty, wet, moldy crawl spaces that, that are not there. So you crawl into the house, you find the air handler, and there's the filter slot, and there's no filter in it, and there's no cover on it either. So every time that system runs, it's just sucking in that nasty crawl space air, not filtering it at all, and sending it into the house. So that's not good. Plus, it's adding more moisture to the load, so it makes it harder to cool that air in the summer. So that's yeah. There are
Lots of issues. And also, homeowners don't realize that air is recycled. It's not, they think somehow fresh air is coming in, where in commercial buildings, right, we have usually a percentage of fresh air that's brought in from the outside. Can you explain that difference, how we recycle the air?
yes, well, and I can confess my own history in that false belief because I remember when I was a teenager, I think sometime when I was younger, um, thinking, I knew that air was blowing out of the air conditioner vents, but I didn't know where it came from. I assumed, like you just said, that it was
Fresh
coming from
air.
outside,
Yeah.
where
I
else
think
would it
we
be coming
all
from?
thought that when we were young. It's like
Yeah,
funny.
I just thought it was all outdoor air,
That's
100% outdoor
comes
air,
in.
which would have made our energy bills a lot higher.
Yeah.
So, yeah, the air gets recirculated in the house. There's a return vent or multiple return vents in the house, and so the air in the house gets pulled back into the system and conditioned and then sent back to the house, and it also gets filtered. Ideally, if you have a really good system, it's filtered with a high efficiency filter.
And it's that same air. It's that if you go into your bathroom and you have dirty bathroom air, that air is
Yep,
getting recirculated through the house.
yep.
There isn't any way, and that's why he's trying to explain to you that that makeup air, when you do pull air out, whether it's your exhaust fans or your hood over your range or you open a door, that air has to get made up in that house. Explain makeup air because people don't understand that. Most homeowners have no idea what makeup air is and why you even need it.
Okay, and when you say makeup air, which form of makeup air are you talking about?
So
Are
if
you
you were to
talking
turn on your exhaust for your kitchen fan,
Okay,
right? People
alright.
are familiar with an exhaust, right? They flip on the fan, they're going to get fresh air, they're going to take all that smelly air out. Explain what happens when that process
Yeah,
happens.
so, whenever you run an exhaust fan in the house, like a range hood or a bath fan, it is pulling air from the house, from the living space, sending it to the outside through those ducts, um, maybe just to the attic, not all the way to the outside. That happens a lot too. And the there's a principle that everybody who's gone through any kind of building science training knows, and that is in the U.S. with our units, we say one CFM in equals one CFM out, or one in this case one CFM out. CFM is cubic foot per minute of airflow. So if your bath fan is moving 50 cubic feet per minute and exhausting that from the house, then 50 cubic feet per minute of air is coming in the house through random leaks in the building enclosure. So, and some of that's coming from the garage, some of that's coming from the crawl space, the attic.
Hence the need to seal these spaces so we're not pulling that nastiness in.
Yep.
So now we've sealed everything, or we're approaching a ceiling. How are we supposed to get the air to come into our homes through a designated area. So you don't want it to pull in from these bad areas. What are we going to use to do this? Explain that to our homeowners so they know.
Yeah. So there are whole house ventilation systems. There's different strategies for doing whole house ventilation. One of them is just to use the exhaust fans that you have and put controls on them so that they run continuously or intermittently to give you enough air movement, air exchange between inside and outside. The problem with just using the exhaust fans is what we just talked about. You don't know where the air is coming from. If you got an attached garage, you got a nasty crawl space, you got a dirty attic. Some of that air is coming from those places. So you better would be to have a whole house ventilation system that's bringing outdoor air in directly from a place where you know it's going to be the best air that you can get from around that house. And, like maybe a gable end vent on the side of the house or something in the back of the house, not right over a garage, not right off the roof. Although I've seen that. Yeah,
Or dryer vent, right? You don't want to be
yeah,
pulling in dryer.
not yeah, yeah. It has to be away from any pollutant sources. So but you know where it's coming from then, and you can bring that in, and there's different ways of doing that. You can just do a supply only system where you bring that air in, you have a controller, you have a duct bringing that air into your heating and air conditioning system. So when the system runs, it's bringing some outdoor air and mixing it in as well. And if the system's not running enough, the controller can turn on the blower and the air handler and bring outdoor air in, even when the house doesn't need conditioning. So you're still getting that ventilation air coming in, and
Mhm.
that's a supply only system. You know where it's coming from. The step above that would be to use something like an energy recovery ventilator (ERV), which gives you some heat exchange and moisture exchange. So in this case, you have two airstreams passing by each other. They don't mix. They go through these little slots in a core of the ERV, and the membrane separating the two separate airflows. One is taking house air and sending it to outside, and the other is bringing outside air in and into the house. They pass by each other very close, with separated by these membranes,
Mhm.
and they exchange heat across the membrane and they exchange moisture across the membrane with an ERV. There's an HRV version that just exchanges heat. Most people need the ERV version though, and the um, the ERV, the balanced ventilation with recovery, will save you money because now, especially in a really cold climate, a really hot, humid climate, you are not bringing that cold air straight into the house. Um, and then having to heat or cool it. Well, if you bring in cold air and you're not having to heat it,
It,
you're bringing it in, and it's picking up a
it's
lot of the
tempering
heat.
it, right? So
Yeah,
it's tempering it a bit.
it,
It's the
it's
best way to describe it
yeah,
to people.
it's bringing
Hmm.
it's capturing a lot of that heat that would be going out with the outgoing airstream and keeping it in the house. So you're not losing that heat that your expensive air that you've paid to heat. Now you're losing the air, but you're keeping the heat from it with the new air coming in. Very
So if you were
clever.
to do a supply only on your HVAC, where you're just bringing fresh air in, that air is sort of untreated, if you will. It's
Yeah.
not. So just think about it. If you were to open a window and just bring in freezing cold air into your home, for people who say, "Well, why not just open a window?" This becomes an issue, right? It's
Yeah. With the type of system I described, the supply only system that's going into the heating and cooling system, the advantage there is that it passes the heating and cooling system. It's not, with an open window, you're going to feel it. With a fan blowing in an open window or through the wall, you're going to feel that. But when it goes through the heating and cooling system, even if it's not heating or cooling at the time, it's getting mixed with house air because the amount of ventilation air coming in is a small part of the total amount of air going through the system.
Mm, I love that. You made that so easy, and that's what I think our audience needs. Like, how do they navigate? Because I think in our industry too, and especially you've been a building science professional for so many years. How many years have you been in the industry?
20.
Yeah. So I think it's easy for all of us too to get in the weeds where a lot of our homeowners, it's very simple steps. When I'm out in the field and I'm looking at these homes, people don't know where to start. They're overwhelmed by, your HVAC professional comes in and says, you need this, you need this. Your building professional contractor comes in and says, you need this, you need this. Your roofer comes in and says, you need this. And they're just at a loss. They're like, well, where do I start? to get a healthy home. So I
Yep.
think you're making it, and the reason we love having you here is because one, you're so knowledgeable, but two, you're just making it really easy for people to assimilate things that they can do. So now that they're ventilating or improving their ventilation, let's talk a little bit about filtration, because if we're bringing outside air in, we're still going to have things like pollen, right? We're going to have issues in the house from the occupants. We're going to have people using combustion materials, people holding on to personal care products, storing paint cans in their house, all of these things that we do as occupants. How do we navigate that? And obviously, source control is one of them, but telling people sometimes that they shouldn't be doing things doesn't help.
Yep. So, before we get into the details of filtration, let me say one thing. And when I talk about indoor air quality, I talk about all the different things you need to do to have good indoor air quality and a healthy home. And filtration helps. Standard filtration, like a MERV 13 filter, a high efficiency filter in your heating and cooling system. That is great for removing particles. It does not remove gases. So if you've got a problem with paint fumes, for example, volatile organic compounds, those are gases. They're going to go straight through your filter because they're so small. They're individual molecules, but the particles are bigger. They're a bunch of things clumped together, and they get caught by the filter. Now, there are filters that can capture some gases, that with the activated charcoal filters and things like that. But the standard filter that you put in your heating and air conditioning system does not capture gases. So for for filtration, what you're doing is you are removing particles from the air, and that could be the dangerous PM 2.5 particulate matter that's 2.5 microns and smaller. And 2.5 microns is about a what is it? Not a tenth. Let's see, a tenth, about a 20th the size, about a 20th the diameter of a human hair, I think, or something like that.
Yeah. Yeah.
It's a very small particle, and the reason those are important is because the smaller particles, well, the bigger particles get caught in your upper respiratory system. They don't make it all the way to your lungs. The smaller the particle, the deeper into your respiratory system it can go. It can make it all the way to the alveoli in your lungs and transfer into the blood system, and it that's never a good thing. So we want to filter out as much of the PM 2.5 and the PM 1 as we can, or zero point 0.1, so that we don't have all the particle load that's getting deep into our lungs and into our bloodstream. So high efficiency filtration, MERV 13, and we can talk about different rating systems. MERV is the one that came was developed by ASHRAE, the Heating and Air Conditioning and Ventilation Trade Association, Professional Association. They do lots of great work. And the MERV scale. Well, how much do you want to go into?
Yeah, yeah, talk
Filtering?
about
Okay,
it. Talk
okay,
definitely, because people don't even know what their filters are,
okay.
and they need to know how they're filtering
Yeah,
and whether they're doing a good job.
yeah. So when you go to a big box store, um, not all filters have a MERV rating. MERV is MERV. It stands for Minimum Efficiency Reporting Value, which tells you right there that it was developed by engineers, because that doesn't say a whole lot, but it does make a nice acronym, MERV. So the MERV scale goes from 1 to 16, and 16 is the most efficient filtration. MERV 13 is really all you need, though, because that gives you really good high uh, efficiency filtration. It removes 85% of the PM 2.5, the really small particles. And the other thing is, with your heating and air conditioning system, as we talked about earlier, that air is recirculating. So it's not just a single pass through. It's, that air keeps passing through over and over again. And each time more of that comes out. So
And
MERV
let's
13,
also, I'm
yeah,
sorry to cut you off. I just want to ask you a
uh,
question so we can kind of clarify for them. What when we're talking about particulate, right? What is making up this particulate? Because homeowners might be like, I clean all the time, I dust, I make sure I do all the due diligence. What How does this get into our homes, and why do we have to be concerned about it?
great question. So a lot of the particulates come from outdoors. So that's another good reason to have an airtight house, but not all of it. Cooking puts a fair amount of PM 2.5 particulate small particles into the indoor air. And uh, cooking and outdoor air are probably the 2 biggest sources, I think. And also,
Pollution. Mhm.
if you are I can tell you another one, if you are renovating your basement and living upstairs, you will see a spike in your PM 2.5 if you're monitoring that at home. I have seen that.
Ah, interesting. What do you think caused the rise in that from the renovation?
Well, it usually happens when, I saw the biggest spikes when they were using the jackhammer on the slab, because that was putting lots and lots of dust in the air.
Silica dust, which is a big, I mean, I don't even want to go into the weeds with it, but when you're remodeling your home, we see a lot of, we get called in as environmental specialists because people get exposed to high amounts of silica dust because the construction is messy and people don't always take the appropriate measures to protect the occupants in the home.
Yep, yeah. Well, we've got the basement, sealed off with plastic, and we've got the zippers on the plastic to go in and out, and, I mean, but it's an older house, and it's impossible to seal it completely,
Okay, great.
but I do have a fan down there, exhausting air from the basement continuously during this whole process, and we had asbestos abatement, and they had bigger fans running during that process.
So lots of particulate. So we've got all this particulate. So sorry to digress on that, but I just wanted to kind of get people to understand where
Mhm.
this particulate comes from.
Yeah, yeah, and I mean, another one is, during COVID, we learned that COVID is airborne, and, at first gosh, that was 4 years ago now that started, and it was so crazy. I mean, we didn't know anything at first, and we were all wiping down our groceries with disinfectant wipes. And we learned it's not surfaces, it's airborne. So these little particles. So when people are breathing, we have bioeffluents coming out of our mouth and out of our noses, and that gets into the air. And some of those particles, if somebody has COVID or flu or a cold, some of those particles are desiccated mucus and was mucus, if they're small enough and they stay in the air as aerosol particles, they float around for hours or days. That virus can stay active on there for a long time and get picked up. So good filtration reduces your risk of getting COVID or the flu or a cold if somebody else is in the house who has that.
And so just go back to MERV. So, because I changed the topic a little bit because I just wanted to explain. So we're talking about MERV and explaining that.
Yeah. So the MERV rating 1 to 16, 13 is where most of the IAQ researchers say is the best compromise between getting high efficiency filtration and low pressure drop. Because here's the thing, the more efficient your filter, when you go from MERV 1 to MERV 6 to MERV 11 to 13 to 16, every step up that ladder is higher resistance to airflow. And we can accommodate that in our heating and air conditioning systems, but the filters have to get bigger and bigger and bigger. And MERV 16 requires a filter that's bigger than most houses can accommodate. So MERV 13 is a really good compromise. And remember, that's multiple passes keep catching more and more particles each time through.
Mm, fascinating. Also talking a little bit about, we talked about filter changes and where do you recommend, like if people are looking to change up their filtration, do you think it's better to go to a building performance professional or to deal with your HVAC professional? Because most people are dealing with HVAC and we're finding that they're not getting a lot of these questions answered. There's a big gap. I get a lot of calls. Where do I go? Because my HVAC professional doesn't know about a healthy home or building performance.
Yes, I was at Brian Orr's HVAC symposium in Florida a couple of weeks ago,
And Brian
and
speaks. He's a speaker on our summit, so he just
yeah,
spoke recently. Yep.
yep. And I was talking to a contractor there who's from Jacksonville, and he said they've got one guy in their company who's anytime he comes across a MERV 13 filter in a house, he says, "Oh, we got to remove that. It's terrible. They don't work." And that's the wrong attitude. So there are HVAC technicians and contractors out there who have those ideas that MERV 13 will never work in a house. Well, it's absolutely not true because I've got 3 of them in my house right now, and they're working great with low pressure drop, low resistance. It's just a matter of sizing it properly. And a lot of HVAC contractors don't do that. They don't measure the resistance across the filter, so they don't really know. They just, so, maybe somebody told them that it doesn't work, so that's what they believe, and we can make it work. So your question about, where do you go? Um, Talk to the HVAC professionals, see if they're on board with it. And there's more and more education happening out there. Brian's doing great work educating companies all over the place, and so you know they would be the first ones to go to, because they deal with that all the time. Although they're in general, this is a big generalization, but in general, the HVAC industry is less knowledgeable about airflow and ductwork and filtration than they are about the equipment itself. They can talk to you about um, superheat and subcooling and TXVs and compressors and things like that, and don't know all the details about those. And to be fair, I mean, they have to know a heck of a lot of stuff to do the jobs that they do. So,
Absolutely.
but airflow and ductwork seems to be where they focus less of their attention.
So, okay, let's get back to filtration a little bit. Any other recommendations? So when people say, look, I've got a occupant living in the house, I've got a family member who has asthma, allergies. We see a lot of, we're seeing so many disease states now that are correlating back to our environments. What else can people do? How do you feel about purifiers? How do you feel about additional purification? What are your takes on getting that air really clean?
Well, so portable air cleaners can work really well. The HEPA air cleaners are great, and they are a higher efficiency filter than the MERV 16 if they're true HEPA. HEPA, high efficiency particulate air, is what that stands for. And there are some HEPA air cleaners that also have built-in ultraviolet lamps so that they can do some more disinfecting. They can deactivate viruses and kill bacteria, as the air passes through.
Mhm.
Um, those are technologies that work. Filtration, ultraviolet lamps, ultraviolet germicidal irradiation, technically. Those things work. I am not a fan of um, additive air cleaners, things that will add hydrogen peroxide or ions or ozone to your indoor air, because there are, I mean, number one, there are known problems with ozone, and with the other stuff, the basic idea with these is that you're doing chemistry experiments with your indoor air, and the idea is that you're putting hydrogen peroxide, say, in the air, and it's gonna react chemically with some of the other stuff in the air, and the idea is that it's only gonna react with the bad stuff and turn it into neutral stuff or good stuff. But it also can react with good stuff and turn it into bad stuff, or neutral stuff and turn it into bad stuff. So you're doing a chemistry experiment, and these things aren't regulated. There are no real standards for them. So it's best to avoid, in my opinion, the additive air cleaners like that. Stick with the things that work: filtration, ventilation, um, and the other things. Now you mentioned, what else can you do? So there are commercial, air cleaners that, the filtration and the UV, I think, are effective and do work. There's also DIY things you can do. There's this thing
Mm,
called the Corsi Rosenthal box, and it's a box fan, a 20-inch box fan with four filters or five, um, or two. I've seen the two filter version and the one filter version, but basically you take a box fan and you put filters on the intake side. And I've got two of them in my house. I've got a couple in my office that we made during COVID. I don't use them that much anymore, but I do have one running continuously in my basement right now. With the renovation going on.
amazing. And tell the audience what that does and how it affects or purifies or cleans the air.
So it's just high efficiency filtration. MERV, generally people who make these put MERV 13 filters on them. So mine all have, four MERV 13 filters that are 2 inches thick, and they're taped together. There's a piece of cardboard on the bottom, and then the box fan is taped on top, and it's blowing air up, out of the filter box. So the air comes in through the sides and gets blown up, and you can what we used to do during COVID when we'd have my mother-in-law over or something, we'd put that in the middle of the room, and, it would suck in air from our breathing and blow it up toward the ceiling, and it would spread out. So, and we
DIY, we
and
love
and
it.
and we didn't get COVID
Awesome.
until last year.
Until you did.
Yeah, yeah, it did finally catch me last year.
So, would you say that most of the time that you feel the HVAC systems, when they're designed properly, are just fine? Like as far as creating good air quality, that you probably don't need these extraneous things.
Most of the time, when they're designed properly and installed properly and maintained properly, yes. But but I would say most of the time, they're not designed properly, installed properly, and maintained properly. I mean, you've been in a lot of houses.
Yes.
You've probably seen mold growing on air conditioners, and if you ever
Oh
opened
yeah.
up one and seen all the nasty stuff inside.
That's the problem I think we have, and we kind of reiterate this to the audience is that if you are going to put in some kind of mechanical ventilation or you're going to implement technologies, they have to be maintained. You can't just put something in, and this is true for anything your car, it's true for anything you use, personal care products, things they require maintenance. And I think people have to understand the more technologies you use, the more maintenance you have to do, and you've got to be doing your due diligence.
Yes, and let me extrapolate that beyond just I mean, you're talking about HVAC, so but it's not just heating and cooling. If you have a whole house ventilation system, it's even more important, I would say, because if the if the heating system's not working, if the cooling system's not working, people know that it's not working. If a whole house ventilation system is not working, they have no idea. I mean, sometimes these things go for years not working, and this is true not just in residential homes, but in big commercial buildings with fancy ventilation systems. They just don't work, and nobody knows.
That brings up such a good point, Allison. So, like I've often said, and I worry about this a lot with homes, and maybe you can ease my mind, is that we are bringing in all this mechanical ventilation, right? So we're sealing these houses super tight and then we're bringing them in. How does a homeowner know it? What if the power goes out? What if they don't know the system's working, like you said? How do we ensure that they actually are breathing good air? Some people could just get sick because the air quality will be really poor. Other people may not. So how do we kind of make sure are there indicator lights? Is there some way? I mean, sensors are great. We could talk about sensors to tell you, hey, something's wrong because the sensor technology is really progressed.
Some of the ventilation systems, whole house ventilation systems, like the ERVs, will have a wall-mounted control panel, and it will give you an indication of what's happening, which was usually okay, but not always. Sometimes it can tell you everything's okay and it's not. But I mean, uh, you need to have somebody who understands the system in your house who can come and look at it regularly, and make sure everything's going
Maintenance.
okay. And also, another part of maintenance is changing the filters. And with whole house ventilation systems where you're bringing outdoor air in, you want that filtered before it comes in. Those filters have to be changed more frequently than your indoor air filters, probably.
Yeah, a lot of the summit speakers were talking about, changing it every month. Like it's much different. I think a lot of people think, well, one, some people don't even know to change their filter. But then we see a lot of people who say, well, I change it every 3 months. And I always say, pull out your filter and look at it and get a gauge on what it's really looking like at 3 months. You may need to change it at two. You may need to change it at one. So kind of really looking at it and saying, wow, my filter's super dirty after, 4 weeks. And that depends
Yep.
right on your occupants, how many pets you have in the home, how often you're HEPA vacuuming, all that good stuff.
Yep. Uh, I change my filters every 6 months
Wow. So you got a super
because
clean house.
well, it's not the house, it's the filters are sized properly. They're high efficiency, 2-inch thick filters, and they have very low resistance across them. The airspeed is very low going across them, and they catch a lot of stuff, but they don't clog up for a long time because they're big enough.
How large are they to give somebody an idea versus a standard 1-inch filter, maybe that you would get at a local box store?
Have so in the system for the main floor of my house, which is about 2,300 square feet, I've got three 16 by 25 by 2-inch filters.
So it's not super big. It's the
No,
same. It's almost a traditional size. Is it what makes it better? Is it that it's thicker, or is it that you have more of
um,
them?
it's yeah, it was bigger. The length by width. The thickness helps also, and so because there's more with the pleated filters, you have more filter area. You could if you pull that out of the frame and stretch it out, you've got a lot of area there.
Yeah. So a lot of people are probably saying, okay, I've got to change my filters. I've got to be in this home trying to navigate allergies because that's a big concern of a lot of our viewers. They want to know how I keep this stuff out. What other recommendations do you have for people who are dealing with health issues, whether it's, they've got autoimmune disease, they have allergies, asthma, all of those good things that we see now in homes?
Here's one that you don't see recommended for healthy homes very often, I think. Wash your bedding frequently, including the mattress pad, because, and you know where I'm going with this, I bet, that's where the dust mites live. And dust mite poop and dust mite carcasses float around in the air, and those are big allergens. So the more frequently you wash your bedding, the more you keep that under control.
Yeah, it's gross. And also, the washing machines now, well, everything is becoming more energy efficient. So those temperatures, those hot temperatures that we often would see to kill off these dust mites are just not there. And sometimes you have to kind of turn up your water heater a little bit and get that temperature higher. We like to see something over about like 140. And unfortunately, a lot of these systems aren't running that warm. So we're getting a lot of that debris left in our clothes, and then we carry it around on us all day. And
Mhm.
so it goes.
Yeah.
What other concerns do you have in homes when we're talking about healthy homes? Because it's a very different perspective, right? We often hear about green homes. We started in the last, I'd say 10 years to really pick up the healthy home aspect. But what are your major concerns and where do you feel that we're falling short?
So the air tightness is coming along. We have made, I mean, in the last 15 years, we've come a long way with air tightness. And in 2011, Georgia was one of the first two states to require blower door testing, and the other one was Washington State. And builders could, they had to get a blower door test, but they didn't have to pass a blower door test. In Georgia, builders actually had to pass a blower door test, and then a whole bunch of other states quickly jumped in with that, and so we have required blower door testing for new homes now in a lot of states, and that's great. In Georgia, we started off with 7 air changes per hour, with the being the threshold. You had to be less than 7. Now we're at less than 5, and according to the model code, the International Residential Code, below 5 ACH, air changes per hour, you're supposed to put in mechanical ventilation. But in Georgia, we've had some revisions to the model code, and so we said, "Well, we're gonna be less than 5, but we don't have to put in ventilation until we're less than 3." That to me, if I were a builder, I would feel that's a huge liability. I would say, if we're less than 5, we're putting in whole house ventilation because that's a liability, and, because less than 5 ACH 50, air changes per hour is tight. That's pretty
Hmm.
darn airtight.
Yep.
And the
And
and the model again, the model code says you need it, so I would say, do it.
mm, definitely. So I'm looking at our time and I want to do a little bit of a fast round with you where we ask you questions and it really helps our audience to kind of understand you and it brings up some interesting points. So we'll kind of get to that. So what is your favorite room in your house?
Favorite room in my house right now is the basement. It's a complete disaster, but I love working down there. I was just down there before we got on, because we're still in the sort of demolition phase. We're not we had the asbestos abatement, which took all the drywall and the old ductwork out, and a bunch and some of the other stuff. But I'm still doing some more demolition. I'm getting the concrete poured this coming week, and so yeah,
Tell our audience
I
what you're doing in your basement, or tell them why you're doing the project.
why I'm doing it is because it was a huge mess when we bought the house, and my father-in-law didn't really do anything with the basement for 20 years, probably 15 anyway. And so we're fixing that up, and it's had some floods in the past, and there was rotten wood behind the drywall, and our radon level is elevated. I've done some testing, um, 7-day test, 126-day test, the alpha track test, and then I've got a continuous radon monitor, and all those tell us that we're up at like 8 picocuries per liter, which is way too high
Hi.
on average. Um, so that's one of the goals, is to get that down, and also to manage the moisture better. Also, I found a huge air leak behind the sheetrock. There was a on the front side of the house, there's these 3 crawl space vents. 2 of them were sealed up, but one of them was behind sheetrock, and it was wide open. So that's a huge win right there.
And just to touch on radon a little bit too, just explain that people often think they buy a house and they were required for real estate to do a radon test. And at the time, they were below, 4 picocuries, and they were in a safe zone. But that can change very quickly, and it can change from day to day with pressure changes in the house. So just kind of touch on that a little bit. You don't have to go into the weeds, but just
Okay.
tell our audience that they need to continuously monitor radon.
Yeah, radon is, the radon levels, as does everything else, it goes up and down all the time, and, I'm looking at my radon levels on my computer right now, and it looks like this. It goes up and down, and when you see the biggest spikes, or at least when I've seen the biggest spikes, is after we have a big rainstorm. A couple weeks ago, we had 5 inches of rain over the weekend, and it shot way up after that because one of the things that happens is, the rain soaks into the ground. It fills a lot of the pores, so it forces soil gases up out of the ground, and some of those are coming up into my basement.
Such fun stuff. And for those who don't know, radon is the leading cause of cancer among non-smokers. So you really need to pay attention to
It's the second leading cause
the
of
second leading cause of
of
lung
lung
cancer
cancer.
among,
Yeah,
yeah, among non-smokers. I'm sorry. Yes.
yep,
And it's invisible, and you just don't know it's there. So you need to
yep,
be monitoring it all the time.
yep.
Um, Second question: what is your favorite thing to do in your house, activity wise?
Work on it.
That's good.
um,
I love that.
yeah, no, I've been doing a lot of different things. Since we bought the house, I've had the soffit fascias and gutters replaced. I put in the EV charger, I put in the heat pump water heater, I put in the new Mitsubishi heat pump, um, and now I'm renovating the basement, and yeah, that's probably my favorite thing. Well, and also, shooting basketball in the backyard, and sometimes having a
Nice.
fire in the fire pit in the backyard.
I love that.
Yeah.
What is something from a healthy home standpoint that you have not done, but you are aware of the problem that it needs to be fixed?
In my house, that's a good question. Well, I'm addressing the basement now.
Mm.
The main floor, it's a 1961 house, and the main floor, there's, I think, a fair amount of air leakage through the walls and the around the windows on the main floor. Um, I may I will get to some of that in some of the rooms. Like, we're gonna remodel the kitchen at some point. We're gonna remodel our bedroom at some point, and the bathroom. But yeah, that's the only thing I can think of there.
Yeah, that's good. Well, you just did a huge basement. The basement was a big one.
Yeah, yeah.
And so, for our audience members, can you just tell them something that they can do immediately? They see this and they say, wow, my house is a mess. I need to start doing stuff to make it healthy. Something they can do immediately that's very economical to start making the biggest difference in their home.
Yeah. So, learn as much as you can. There's a lot of great resources out there. The US EPA website has tons of good information on it. They have a a really good document if you want to really dive in and understand all these different air cleaning technologies, no, air cleaning technologies and how they work and pros and cons of them. They have a document called something like Technical Summary of Air Cleaning Devices. I can't remember exactly what it is, but it's like an 80-page PDF you can download for free. Really good information, like lots of good information about radon and ozone and things there. Um, buildingscience.com, Building Science Corporation website, my website. There's lots of good free information out there in a lot of places. Green Building Advisor.
Mm. Where can people find out about you? So give us all the good tidbits. If people want to contact you, if they want to
Okay.
email you.
Yeah. So my website is energyvanguard.com. And that Vanguard. A lot of people mix up the U and the A there. It's Guard, Guard. And I'm very active on LinkedIn as well. So energyvanguard.com and LinkedIn and my email. You can send email to evinfo, well, abailes, abailes at energyvanguard.com.
And what do you help consumers do? So if someone were to contact you, how would you help them?
The main thing we do is residential HVAC design, third party all over the US and a little bit in Canada and Mexico.
Amazing. Well, we need you. All of our listeners and myself, everybody, we need you because it's so important. And just tell people, I mean, I believe this and I'm sure you do too. The HVAC systems in our homes are the heart and lungs of our building, right? I wish they were put into design way before, and we've talked about this with Brian, or these things get considered much later in the process of building, where I think they should be considered when you're first building. But just tell a homeowner who may be building a house how important the HVAC is and how you need to take it into consideration.
Yes, it's very important, and I can tell you the clients that we have the easiest time working with are the ones who come to us early in the process. You know, when they have the floor plans and everything pretty much set, but they can still make some little changes here and there, so that for example, if they want to, they have a nice big mechanical room in the basement, but there's no way to get ductwork out of it because you got stairs on one side and beams on the other, and there's only a tiny little place to get ductwork out of there. So if you come to us early enough, where we can have some impact on finding a way to get the ductwork out of there, that helps a lot. So start early.
Thank you so much. Well, I am so grateful that we got to have this conversation and this time with you. You are an amazing treasure and you know so much. So I hope our audience takes advantage of everything you've said and reaches out to you for any questions that they might have.
Yeah.
So thank you
Well,
very much.
well, thank you for having me. It's been great.